Hello everyone! Today we will talk about the synthesis and the evolution of the iron porphyrin. Credits to Faiza, Anissa, and Aini. So, basically, why we need iron porphyrin or heme in our daily lives? The importance of the iron porphyrin for the iron deficiency anemia. First, it will decrease the work productivity. Next, it will increase the child mortality, will increase the maternal mortality, and also it will mild to moderate anemia that may increase susceptibility to infectious disease. The iron deficiency for non-anemia patient. First, it will cause the neurophysical effects. Second, it will reduce the work capacity. Third, it will impair endurance capacity, especially after aerobic training or any extreme activities. And lastly, it will respond to the iron therapy. The roles of iron porphyrin in human body. First, it has the ability to bind with oxygen because of the presence of the iron atom. Second, it serves as an active site for complex protein, for example, hemoglobin and myoglobin. It also contributes to the red color that found in muscles and blood. For the synthesis of iron porphyrin, glycine will react with succinyl-CoA to form 5-aminolevulinic acid. Then, dehydration occurs which produces porphobilinogen. Using PBG deaminase, deamination of 4-amine will form hydroxymethylbilane which further undergoes the removal of water molecule to produce uroporphyrinogen. Uroporphyrinogen will decarboxylated to coporphyrinogen which further oxidizes using CpG oxidase and form protoporphyrinogen. Using PPG oxidase, protoporphyrin is then produced. Lastly, ferrum ion is added to the ring porphyrin with the help of ferrochelatase and heme or iron porphyrin is finally formed. Iron porphyrin can be characterized by three spectroscopy which are first FTIR, second UV visible and third X-ray diffraction. The FTIR shows the functional groups that exist in the iron porphyrin molecule. From the table, there are two types of bonds which are the stretching of CH and CO that exist in the molecule. The porphyrin molecule is a 24-member ring with 11 conjugated and delocalized double bonds. The electronic absorption spectrum of porphyrin ring shows several transitions. A weak transition from ground state to the first excited state results in 4Q bands with weak intensity. The strong transition from ground state to the second excited state yields solid band with strong intensity. X-ray diffraction shows the geometry of the compound. The bond length of N and Fe is 2.054 Armstrong. The bonding between N and C is 1.382 Armstrong. The bond length between C and C is 1.408 Armstrong. And finally, the bonding between C and O is 1.423 Armstrong. While the bond angle between the atoms N, Fe, N is 90.48 degree, while the atoms of C, C, and C is 117.5 degree. while the atoms of O, C, and C is 106.5 degree. And finally, the bonding between the atoms of C, N, and C is 106.4 degree.